All right, we are live now. Hi
Great.
everyone. I'm really excited to host Andre Keane, co-founder and CTO of Autility. I have been looking into Autility's work and I believe they are doing cutting edge work and pushing the boundary in AEC tech. I'm really honored to host Andre on the show. And one thing I would like to mention that Autility got nominated for Nordic PropTech Awards 2021. So congratulations, Andre, for that.
Thank you so much. It was a fantastic nomination for us, and really excited to be here and chat with you about it.
Nice. So, Andre, can you share some highlights of your career and early days, how you discussed this idea of developing Autility with your co-founders and how it grew?
Yeah, so brace yourself. I do not have a very straightforward past. So I started studying computer science, and I did that for 2 years before moving into naval architecture, so designing ships. So complete 180, and I ended up working in the shipbuilding sector for a period of 3, 4, 5 years. But I worked with kind of digitalization projects and initiatives and was responsible for that in a big Norwegian company called Ulstein, designing these kinds of ships. And it's always sort of been looming for me, this IT background. And given the opportunity to really kind of leverage that, just triggered a lot of things for me. So I really wanted the opportunity to go deeper, like properly deep. So I started in a consultancy company locally where my wife is from, and they gave me this flexibility to kind of learn the things that I didn't learn in school and weren't able to sort of build upon. And that's what I did. So I worked with IoT projects, started with machine learning projects, and got familiar with cloud services. So just like gradually everything that you this with like emerging technologies, like everything you associate with emerging technologies kind of became a passion. And what we saw, we had some projects as the consultants with real estate companies, mainly related to energy projects like renovation, saving energy, tuning HVAC systems, stuff like that. And we just saw, how much these companies told us that we really want to apply these new technologies, but a lot of them don't know how. And the ones who do know how think that it's really difficult to scale. Right, so it's we started digging into this, and we found that just more and more real estate, and for me, actually, real estate is mostly like operations. So we don't focus that much on construction, but that might change in the future. So when I'm talking about this, it's more like existing buildings in operation. And these type of owners, facility managers, even some tenants, they were really struggling implementing this in large scale, like throughout the organization, throughout their portfolio, because it is difficult. And that was the conclusion that we reached, like really, really difficult to manage all this stuff. And if you just take a quick sort of peek into prop tech without having really navigated that space before, it's an ocean and it's really easy to get lost. So this kind of triggered a solid motivation, and we actually got our me and my co-founder, we got the company that we were working for as consultants to kind of sponsor this as a new company. So they backed us in creating this new company, and that was pretty much it. And we went through a lot of processes with accelerators, and we had a lot of advisors in through early phase investors, and it just seemed like we were absolutely 100% lucky with everyone we connected with, because it seemed to be all the right people at the right time. And finally, things are starting to materialize in terms of development, because we're a relatively new company founded in mid-19. So we've only been doing this for roughly 2 years, and we've only been developing for roughly a year and a half. But now things are starting to hit the market, that we're starting to really demonstrate what is possible and how, you know, new technology can be applied in this sector at scale, you know, really solving those juicy problems that have been looming there for a long, long time, kind of organizing this data that is really hard to get, that is really hard to standardize, and even harder to use. So that's pretty much like our story and where we're at today.
I see. That's quite interesting. You have like such a multidisciplinary background, and like you bring that approach in our field. So I'm curious to know. So many times when like people outside AEC look at the problems in AEC and the need of technology, and they think, okay, this might be a way to solve that problem. But once they start building it, there are another set of problems or resistance you face from the industry. So were there any moments like that you faced?
Oh yeah, all of them. It's that's the typical way. These, if you go to an owner or a facility manager, they might have, if you're lucky, some sort of digital guy or a girl. And the way they typically want to start a project is, okay, we want to work with artificial intelligence or with IoT, or you know, they start in that end. And then if you're even luckier, they might have some sort of, you know, goal as to what they want to achieve. But once you start sort of working your way back from, you know, okay, we want to do predictive maintenance using artificial intelligence for this and this building. Okay, what's the next step? Where do we get the data from? Right? And then you go into these buildings, you see that this HVAC system was installed in 1984 by some guy, and the other HVAC system in the same building with the same brand, same model, same year was installed by another guy. So the data coming from these two systems that are identical looks completely different. So it's kind of a smack in the face, you know, for these companies who they want so much, but it's so hard to overcome these steps that just really require properly low-level competence. Like you need to know what you're doing all the way down to the floor, and how these systems work, how you extract data from them, how you communicate with them, and not least, how you organize that information. Because that's one of the big things, is that there is no existing standard for how data should look like coming out of, you know, these sources. So that's one of the major problems that we're trying to address, is both extracting that data, organizing it, so that you actually can move forward in these projects that you know, want to create value from.
I see. And also, like, I feel AC industry is particularly not very known for open sourcing their code or data sets, so it adds another challenge to that problem. And
Absolutely.
another question I have is, moving from consultancy to CTO of a company, like what were some challenges you faced in terms of technological development? How you prepared yourself for that role?
It's a very good question. So let's put it this way. I knew sort of low-level IT at a pretty good level. So I was like fluent in Linux, and I could program something, but I wasn't what you would say a good programmer. But I understood the principles. So that was enough to get us started and get our first customer. And then, you know, once we get our first customer, you have to scale, build a team. And that was a completely new process for us. Neither of us were, founders from before. We didn't have that experience. I, as the technical guy, did not have the necessary cloud experience to sort of say, okay, we need to build it in this way. So that was all kind of try and fail and learn as you go. But the key there was to try very, very often and very, very quickly, so that you fail almost immediately and can learn from that failure and build the next step on top of that. So we slowly built a team from, it was myself and my co-founder Sebastian for about 5 months. Then we hired a project manager who then helped us build the developer team. So we were about, I think, 5 developers by end of February 20, and had started the process of developing. And that progressed quite well. So, we were able to balance customers and development with, investors looking for how many customers you have, what are you earning, how is this being received in the market, in order to, increase the number of developers. So now we're actually at 21 employees, and we're really gaining speed. So we're looking to double that by March next year. And that's really exciting. So, but one thing I will say is that I don't know if this is for all AEC, but at least for real estate, we very quickly found out that, a lot of these companies are not mature enough to want to necessarily buy data, right? They would they prefer to purchase and pay for applications. They want the buttons, the graphs, the results, which meant that we had to start in the other end. Like we weren't, in the beginning, we weren't solving these big problems with extracting data and organizing it and making that available for, intelligent services. But that was always our goal. So we kind of knew that in the back of our heads, and were able, luckily, to build the whole platform with that in mind, right? So we kind of facilitated those, that foundation, those building blocks, so that when the right time came and we found partners and customers that were actually interested in solving that big problem with us, we had that sort of ready to build on, which was, I think I can say that was a pretty big differentiator for us, that enablement, really.
I see. And earlier, you mentioned about being at the right place at the right time. So I'm curious, like, what are the things you look when you hire a new person in your team? Do you look for background in AEC with software development, or proper software engineers? Like,
so I'm a relatively firm believer that as long as you get smart people on your team, you can guide them, and they will learn very quickly the things that they don't know. As long as they have a good foundation in what they should know, the rest, I honestly wouldn't care that much about. It's like, if we're looking for backend developers, I just want to know that they properly know how to code. If we're looking for data scientists, actually in data science is a little bit twofold, because on one hand, you want an amazing guy who knows all the different architectures and methodologies. But on the other hand, we also have really good experience with hiring just super smart people, and they have learned very, very quickly. And they have appreciated that freedom to learn, which kind of self-compounds, in terms of motivation and how much they actually contribute to what we want to achieve. So I would say we've been very flexible, like both kind of properly what you call tailored people to a specific role. Take Antonio as an example, who I believe also has been on your show, and it was how maybe you found me. He is kind of a unique guy in terms of he's an architect, but also a developer. So he knows both spaces very, very well. Whereas other people on our team, they just know programming very well, and we've introduced them to these new concepts on how to actually solve this kind of data spaghetti, which let me tell you, is not a very established method in the industry, actually in any industry. It's a very new way of doing things. Also new for us, obviously. So I think a lot of a big part of our team has really appreciated being a part of this same journey. You know, we're all learning, and we play off each other, and it just kind of benefits the whole team, really.
I see. And my last question before we move on to the presentation would be, is the company like bootstrap, or you guys received Series A funding? Like,
depends what you mean by bootstrap. We started the company together with our previous company, who stood for the capital of actually creating the company, and then we had a series of very early phase investors. So our current chairman of the board, he's ex CEO of Siemens in Norway. So he kind of knew this area and wanted to come in early. And that was one example of just like, you know, right place, right time, because he's been a tremendous asset for the company, as has, you know, the whole board. And we've built from there. So we haven't reached any Series A level yet. We're still kind of pre-seed, but we have received a lot of official grants. Luckily, Norway is pretty good on that, supporting startups. And we're actually receiving a pretty big one this fall, which will enable us to scale even more, which hopefully will lead to a Series A.
that's exciting. So, can you like present us more about Autility and?
Absolutely. So let me see if I can share my screen here. So can you see the presentation?
Yep.
Perfect. So please just feel free to ask questions along the way. I just wanted to take you on a little journey through what it is we are working with, what we are trying to achieve, which is quite ambitious. So how we're going about that type of ambition, because these types of problems are not solved overnight. These are big, big problems that take time and a lot of thought. And what that really means in terms of technology. So I'll just try and quickly sort of dive into it, and we'll see where we go from there. So obviously, as we've already mentioned, the big thing in the industry that we've seen is that the data, you know, between the source and the value creation, the actual usage of the data, it's a big, big problem. It's very difficult to actually extract useful data from more than one system at a time that you can leverage together. And the typical picture that we meet when talking to various actors in the market oftentimes looks like this. They have, you know, one system for that, one system for that. They have some sensors over here. They have a couple HVAC systems that actually do have a BMS. Some don't have a BMS and just have controllers. They have something with APIs, something without APIs, and at best, they've been able to sort of hook up one or two of these and perhaps make those systems talk to each other, like maybe work orders and maintenance with invoicing. But we have never, ever experienced or seen any case over the whole world that has been able to make sense out of extracting information from all of these systems at once and putting it together in a way that makes sense, right? In a way where you actually can use it to do something beneficial. So what we're talking about here is saving time by automating things, reduce unnecessary costs, or increase the value. So earn more money, or just actually feel like things are easier to work with. And how we go about this is kind of threefold. So our mission is really mainly part of three categories that is going to be a red line throughout this whole presentation. And the first part is solving that problem that I just mentioned. So it's about enabling scalable data extraction from any system and organizing that so that you're able to actually implement these technologies that we're talking about, so that you can use AI, you can use simulation, optimization techniques to actually do something. And we want to create simple apps on top of that. So we don't just want to stop, at serving data or serving a properly good artificial intelligence inference engine. We want to use it. We want to put it in context and provide a simple to use application. So pretty much like an end-to-end thing, which is a big ambition. And our vision is to actually create autonomous buildings. And for us, that doesn't necessarily only mean the building itself. So it's not just about, automating temperature adaptation, ventilation adaptation to suit tenants' comfort levels, at the same time as optimizing, costs of electricity and stuff like that. It also has to do with things outside of the building, maintenance, access control for new tenants, upholding the value of the building. What about even, finding new tenants, like visualizing vacant space in VR, for example. So there are a lot of things that are possible based on a core set of, let's say, products and technologies that I'll be walking you guys through. So first of all, the big thing here is how we extract this data and actually make sense out of it. And the categories of data that we typically meet, it's three part. The simple ones are typically external data. So open APIs could be weather, it could be traffic, things that are openly available. The second, and a little bit more difficult sometimes, are proprietary applications. So software that the customer uses in their day-to-day operation. Could be ERP system, CRM, invoicing, or remote control for the HVAC system. But the most difficult one is actually the building itself. Because as we've experienced, the systems that operate buildings today, being typically HVAC, access control, fire and safety, and lights, and a few others, they could have been installed in the 70s and not really upgraded to this day. So that means that these systems were designed and installed before kind of internet was even a thing. So it's self-explanatory that a lot of these systems are not designed with two-way communication in mind. So one thing that we're building is kind of a plug and play extractor towards these building systems. So we hook up a computer that basically is designed to scan whatever exists on whatever bus that we're communicating on. So if we hooked onto a USB or a network interface, or the older ones like RS-485, or whatever kind of interface is in the building, this system is designed to look for whatever is out there and recognize it so that we can extract that information and send that to the cloud. So then the next part comes into play here, which, for lack of a better term, we like to use contextualization, because, think about it. How do kids learn how to speak a language? Through context. They learn how things are supposed to happen, supposed to look like, how you're supposed to structure a sentence. And that's kind of what we're doing with this data. We're learning how to put it all together with certain standards that makes the data coming out in the other end look completely different, but make much more sense. So I'll get back to that in a little bit more detail, that hopefully will make a little bit more sense afterwards. The second part that we're focusing on is leveraging that clean, standardized, ready to use data from these old, difficult systems to actually move from data more towards intelligence. And by intelligence, we mean just applying some sort of emerging technology. The typical examples are AI and automation. AI to kind of synthesize some of the value coming from this data. So we might have data coming from, fans or compressors or other vital components of the ventilation system in a building. And you can use relatively simple AI techniques to make that more valuable. One example is anomaly detection. So if something abnormal happens, creates a spike, that's very interesting information for a facility manager to be proactive in terms of monitoring the situation and even preventing a potential failure. Another example I'll get back to a little bit later. But automation is also, and by automation, we mean kind of automating manual tasks in this case. And that's one of the obvious upsides to this, because once you've connected all these different systems, it's very easy for us to take information from one place, treat that, and do something in another system. So having this data standardized is actually a massive, massive, massive boost for us in terms of this automation, because it's standardized, it is so easy to automate. If it was not standardized and you would have to do integrations to each and every one system based on the terms from that system, this wouldn't really be possible at large scale. And again, I'll kind of explain what I mean by that a little bit later. And what we're working towards is packing all of this together in apps that are easy to understand, easy to use, typical software as a service that should just work out of the box and provide something valuable from day one. And that's what I think a lot of the industry is missing a little bit, is that they start a lot of these projects and it takes so much time to demonstrate and really show that, okay, you put in a lot of effort. Let's see the results in 6 to 8 months. So we're really trying very, very hard to make this happen as quickly as possible, like the whole pipeline, extracting data, organizing it, applying some sort of intelligence, and presenting that information that is actionable, so the users can actually do stuff with that information. So that is what we're trying to do in a nutshell. And kind of to reiterate a little bit, the difference between how this is experienced today is data is not open and not interoperable. The systems that we're talking about are 99 out of 100 times in some silo that is relatively difficult to break into. And the system is not designed with interoperability in mind. What I mean by interoperability is that a standard interface for two-way communication. It makes by default, things manual and reactive. There are so many different interfaces that you have to, there's an example. Actually, we have one customer who, as a facility manager, so they organize and work with a lot of buildings for different customers. And even in the same building, they can use the same system, but they have to log in two different places because they handle information for two different customers. And it's just stuff like that that kind of makes it very apparent why this industry, first of all, is eager to modernize. But secondly, faces a lot of challenges because the foundation just isn't there. And, to end up with, our goal is obviously creating autonomous actions. So not just automatic, but self-adapting intelligence that does things by itself. You shouldn't need to specify any parameters or give it any guidance. To be truly autonomous, it needs to do it completely by itself. And that has a lot of implications. So if we kind of take this back and talk, okay, autonomous buildings and autonomous building operations, what does that mean in terms of technology? You cannot start with autonomy, and you cannot perform truly autonomous functions without this inter-dominion foundation. So it's just not possible. And that's what I think a lot of initiatives and companies are getting wrong these days, is that they're talking about autonomy, but a lot of them are talking about autonomy within kind of a niche. Like they've performed some end-to-end test with some sensors, and they bring in the weather to control the ventilation system better, and they call that autonomous. But that's not really autonomous. That's at best kind of automatic and relatively smart. But in order to create autonomous functionality, you need to talk about not only AI and not only different forms of AI. I mean, you need to have a natural language processing in this pipeline somewhere. You need to be able to read static documents, PDFs, Word documents, Excel files, tables. Those things are used actively to perform, these operations today. So you have to be able to ingest that information and understand it. Digital twins, in terms of being able to leverage the geometry of a digital twin to perform simulations and optimizations. The kind of visual interface itself is not by default necessary, but it's a very nice feature for a lot of users. You need to be able to have a smart automation engine that can basically function as, the many automation engines that exist for smart homes today. Like, what we're talking about is, if this happens, something else should happen. And if you can couple that with the standardized data coming out from these buildings, there's really no limit to what you can automate. And then you can start talking about, applying more and more intelligence. And what I mean by intelligence is pretty much AI. Like, what is AI good at? It's good at recognizing patterns and using those patterns to infer an action. That's really a lot of the time what we need in terms of smartness. We need to recognize in a huge amount of data, much more than a person would be able to fathom and understand and make sense out of what patterns actually exist and perform some action on top of that. So these are kind of the three major phases that we as a company have been operating on. And as I mentioned earlier, we realized relatively quickly that we needed to build a front end. We needed to build a product, something that was clickable and visual. So that's where we started. We delivered that early this year, and now we're well into the automation phase. And it looks almost like this. So we started by integrating a lot of data into one place. And to begin with, we focused on energy data. We focused on indoor air quality data. We focused on technical monitoring, so pretty much maintenance data, and work orders as a way of actually performing actions between these domains. And then we started developing diagnostics around this data. So moving from just showing information to actually diagnosing that, okay, we think we've found an anomaly here, and we believe this is the cause. And then surface that as something to whoever that information is relevant to. I mean, that's in and of itself kind of a big step from how typical operations are today. But the next step that we're currently working on is making this all perform automatically. And at least we believe that's the only way that we're truly going to reach any sort of autonomous functionality. And this is really what we're talking about. So pulling together a large amount of data, the first thing you have to ask yourself is, how do you organize it and visualize it? So we have two approaches to this. We, on one hand, we've tailored a set of simple, understandable KPIs that we process the data coming in, and we just surface simple colors, really. Is it green? I don't have to care about it. Is it orange? Maybe I should care about it. Or is it red? That is definitely something that I should care about. And on the other hand, we know that it is very important to facilitate flexibility in terms of how you visualize this data, because different users or different companies might have different reporting schemes. They might have different certifications that they need to put together information on. So we also built in a self-service business analytics tool. So that's completely integrated and based on the same data, but it enables the user to put together the information however they would like, as an individual or as a company. But it also allows us to create ways of visualizing information that we don't have in the front end itself. So we could create templates for example, monitoring energy usage and putting that together in a way that enables not only monitoring this information, but also providing actionable information. And it's just a very easy way of surfacing more and more information the way that you need it. So I'd like to also highlight that is built on open source. So we really try and be active in the open source community. So we're also one of the main contributors to a digital twin library that you're familiar with, IFCJS. Antonio, working with us, is one of the main contributing authors. And that's kind of one of our ways of giving back, because we've really received a lot based on open source. So it just seems fair, to be honest. Let's see. I see that I forgot to mention a term here. So we've talked about integrating data and contextualizing it, but the name for that process that we've eventually stumbled upon, it's actually called, and it has a Wikipedia page, so I guess it's official. It's called data fusion. And that term originally came from the autonomous vehicle automotive industry. And what it really entails is bringing together data from many different sources and putting it together in such a way that what comes out the other end is more valuable than what came in an isolated fashion. And to us, that means contextualizing. So by contextualizing, we actually take data and we add information. We contextualize that data. What comes out the other end is more than what came in. So that's what we mean by fusion power data. And that is actually the biggest enabler of everything else that we do. Without that technology, we would still be on a level playing field in terms of incorporating artificial intelligence, automation, digital twins, everything. So that's really the core foundation of what we're building on and actively working on. That is actually one of our biggest development hubs today, data fusion. But based on that process, the information that comes out is completely standardized. Regardless of domain, it could be from the building itself, it could be in a smart city perspective, it could be a construction phase, it could even be completely separate domains like finance. There exists a lot of so-called ontologies, which basically is a fancy word for how you should map data for a specific domain. And we leverage all of those to put together a huge information model that enables all of these different domains to communicate together so that the digital twin knows what's going on in the automation system, knows what's going on in the front end, what data is being sent to different dashboards. They're all talking about the same things. So in essence, really, that's kind of that's the core of what we're doing. And we're just using that core to build kind of cool things on top of that. Like the digital twin, which I think has tremendous potential, not just as a tool to navigate information. We talked about a little bit about simulation and optimization earlier. Of course, that's also relevant, but you know, if you think big in terms of this generic information model, coupling that with the one thing that is common for all this information is the asset, right? So it's in this case, if we're talking about facility managers or property managers or tenants, they're interested in the building, the physical building. And that means that we can connect any information to that building in the way that makes it logical. And they can navigate all of that from the digital twin. So that's what makes it kind of cool. I've seen other digital twins that have parts of that, like they have real-time data. Maybe they've integrated work orders and some maintenance information and maybe something else. But by doing the integrations the old way, so without this fusion power, it's just very hard to scale. That's kind of the truth of it. So that's the high level pitch. If we go a bit deeper, I'd like to try and take you through each of these three steps. So data fusion, intelligence, and what we call applied intelligence. So really how you actually consume the result. So if we look into data fusion, I briefly mentioned the high level things, but I didn't say the alternative. I didn't kind of go into why this is necessary. And the alternative today is just doing one-to-one integrations with whatever system you're talking about. If it's an open API, or if it's some access control system, whatever it is, if you keep working with one-to-one integrations, meaning that you extract data from that system and then you create some sort of reporting or maybe an algorithm or something based on how that data looks coming straight out of that system, it's very quickly going to become a non-scalable event. Because you can imagine ventilation systems are typically the best example of this problem. And I mentioned it earlier, but you can have two identical physical systems and the data coming from them can look completely differently. So if you were to create a smart algorithm optimizing the indoor air quality and comfort level versus costs and maintenance considerations, for one of those systems, you would have to map your algorithm to the other system as well to do the same thing. By implementing this data fusion process, you don't have to, because all the data becomes standardized and you can create one algorithm that points to generic parameters. And that's one of the biggest selling points of doing it in this way. So how do we do that? I mentioned something called ontologies. And ontologies, luckily for us, is something that researchers in academia have been working on for decades. So in our case, we were very happy to discover that there exists a whole bunch of ontologies actually for different real estate applications. So take a building as an example, there are probably 10 different ontologies, good ontologies that describe how they feel data representing buildings should look like. So they basically say, okay, if you have a sensor, the sensor type should look like this, the measurement should look like this, the placement, location should look like that. And they basically give you a map of how you should structure your data. So the difficult part of doing this is there are many different ones. How do you know which one to use? So we've actually ended up kind of building our own to meet the demands and requirements from the market. So we've put together a lot of different ontologies to create almost like a master ontology, like one big model that represents all the information that we need it to represent. And if we figure out that another ontology just over time becomes better, it better describes the information coming from this domain, we can just swap it. We just plug out the old one, put in the new one. And that's what's beneficial about using ontologies, is that they are inherently generic, which means that it's very easy for us to extract and input different elements and components of these informational structures. So the ontology itself is basically a standard. It's a map of what data should look like. The implementation of that map is a whole different question. So how do you actually apply that to the data coming in? And the data most often is coming in real time. So you have to ingest this data. You have to look up towards these ontologies to ask, I'm a temperature sensor. What should I look like on the other side of this pipeline? And that is a non-trivial process. That is very, very complicated, which is why I think this is not very, very well known, maybe, way of structuring these kinds of data and working with this kind of data. But what comes out the other end is just, it's undisputably valuable. So just as a quick kind of dumb example, we could have data coming in, and I mean, this is relatively nice looking data. It's JSON, so that's like any developer's dream. We've seen much worse data than this. But what this pipeline really does, what data fusion does, is we ingest this data and we apply a standard of what this data should look like when we know what the data should look like. In some cases, the data is so obscure that we can only apply machine learning algorithms to try and identify what they really are. Like, for example, if the parameter names just don't make any sense, the data doesn't look like it does anything, we can apply machine learning techniques to try and recognize, based on experience from other installations, what this really is. And it can discover that, okay, this parameter here is actually, it looks like a set point. So if you adjust that, stuff is going to happen in the building. Like, you're changing some setting somewhere. And by changing it, actually performing the operation, we can also record the response. So there are various ways of interpreting and discovering what this data means, but most of the time we're able to map these directly into ontologies, relatively straightforward. And what comes out the other end is actually more than came in. So what came in might be a data point, but what we could add, is, for example, what type of data point? What physical device is this coming from? What unit does this device measure in? Is it Celsius, Kelvin, Fahrenheit? And we can actually do conversions based on that. So we can add transformations that are completely generic. For example, calculating the efficiency of a fan or some system, and put that directly into the result that we can shove straight into a report, to a notification, to the application, wherever. So that's the benefit of this process. And taking that one step further, what we want to do with that information is augment it. We want to make that information even more valuable. And the typical way of doing that is mainly threefold. So AI is the obvious first, it's what everyone thinks about, and we use AI in quite a few different manners, but mainly it's about, surfacing diagnostics by identifying anomalies, by recognizing patterns, by forecasting. And that provides a lot, but actually something that we recently started is also working with machine vision. And that is really interesting, because what you're basically saying is that, okay, I have a camera feed here looking at something. What do you want to extract from this video feed? And that could be literally anything, as long as you can train a model for it. So what we started with was recognizing typical objects. So you can point a camera outside the building and count the number of cars in the parking lot, the number of free spaces. You can count people inside the building, so you have a live occupancy, which is useful for COVID restrictions, which is useful for tuning the HVAC system. and temperature adjustments, stuff like that. But we quickly found out that you can also use this. You could just point it at a door, for example, an escape route, and say that if some object is within, this distance of the door or within that width, that's actually blocking the escape route of a building, which is not a good thing. And we can send an alert based on that. So machine vision is really interesting field because it's really up to your imagination and, of course, the quality of your data scientists and data engineers to come up with a way of extracting that information from that video feed. So that's something we have really high hopes for. We've done some pilots over the summer, and it's looking actually really good based on, again, open source technology, cheap, like one of the cheapest AI machines out there. We use the NVIDIA Jetson, which comes in different forms, but the most expensive one I think is under $1,000. So very quick, simple, or relatively simple and cheap way of extracting information that previously, in many cases, wasn't really possible without a lot of effort. Another example for us, of course, is automation. So by being able to communicate with different systems at the same time, and that you're talking about the same thing because you have one definition, it becomes very easy for us to trigger actions across these systems. So in this example, and this is a very typical example that we've encountered quite a few times, and that is a combination of a component needing maintenance and whatever happens around as a consequence of that. So say that we have an algorithm monitoring this component. We discover an anomaly, we trigger an event based on that we think this is actually an anomaly, something that you should consider putting some resources into. We automatically create a work order based on information from maybe a BIM model or maintenance documentation or other external systems. We know who performed maintenance on this component before, who's responsible, like what company does the owner have a contract with to do this kind of work. We can trigger that order, send it to them directly with raw data, with diagnostics, with the documentation following this component. And at the same time, we can also inform tenants. We can inform the facility manager, who should probably stop by and stick his head in there. We can inform the property manager. And we can even give the technician digital key and AR-based indoor navigation to find the relevant component and open the relevant doors on his way. So just in that example, we're talking about, I don't know, like 5 or 6 different domains and systems that previously, before the era of data fusion, really would take so much work and time to actually complete. And as a result of that, this is almost trivial because of the standard data and the automation engine. This is totally possible, which is quite exciting. And of course, the other use case is simulation optimization. This can be used in many different fashions, but for us, the most talked about typically and the most relevant is optimizing for the heating and ventilation system. So taking into account, how many people are in the building, how is the building used, what is the weather going to be the next 7 days, how does the sunlight affect the different facades of this particular building. Also considering the cost of energy, spot prices. You also, in Norway, you have energy tariffs. So based on how much wattage you use at the same time, you might have a really high bill, as opposed to if you were able to kind of distribute that load and lower that peak. So things like that is super relevant. And that is made possible through the combination of having a digital twin and having the infrastructure to read those necessary, that type of data, and having the competence of working with different AI techniques and optimization techniques to actually perform these computations. So lastly, this is my last slide, and there have been no questions. So I'm just talking on both exhale and inhale, but feel free to shoot me at any time. So
Okay.
how do you use this information? That is, even though we may be solving really important problems in the previous stages and enabling companies to get the most out of that data, it really doesn't matter how good you are at those two stages if you can't surface the result. So I've just brought up some examples of how both we envision doing this, because this is not all complete and ready today, but these are things that we're working on, either in the back of our head or really far in the front of our head. So AR is a very obvious use case for us, because it both has this very nice feature of being able to surface the most interesting information given the scenario. So based on where you are, what you're looking at, and the time, AR can surface information that is relevant to you, whether you be a technician that you're in the ventilation room, as this is in the building that we sit in today, actually, and you're looking to diagnose some things or just check up or perform some routine inspection. Or you could be a tenant or even a guest of a tenant needing some navigation and access to where you're going to get through the right doors and to find the relevant space, external coming in for a meeting. Scan to BIM. Now, this is a big topic. This is also very relevant for AEC. And we don't have the solution. So just don't want to get your hopes up there yet. But this is something that we're working with, because over time, we've built a really strong base of data scientists. And we do work quite a bit with 3D scanning, actually. So for us, compared or in operation compared to, I would say construction, I guess we don't need the same accuracy a lot of the time, unless we're talking about renovating and not having as-built drawings. So for us, it's mostly about, aesthetics, importing this into the digital twin, putting information on top as annotations in this model. But we're also looking into ways of utilizing that information in other ways. And here, really, AI, there are a lot of interesting different topics of research going on in this field. So both converting point clouds and mesh files to floor plans is relevant. Also actually converting floor plans to 3D, but also performing object classification in 3D can be very relevant. So if you go back to the AR, AR would actually get much more context if it knew what objects it was pointing at. And based on a 3D model, it's also much easier to position yourself in AR. So all of these things are kind of connected, but scan to BIM is a big kind of goal for us eventually. So we're moving towards it, at least. And of course, automating things. This is one of the most obvious use cases, and providing a simple to use interface so that basically anyone can leverage the basic principles, mainly pioneered by smart homes. If this happens, I want this to happen. Very simple. But it requires standardized information. So if you don't, if you don't talk about a sensor event in the same way between two vendors, it very quickly becomes very complicated. And of course, moving from reactive to predictive, and relatively soon even prescriptive. So not only being able to forecast that something's going to happen, but provide the user with a detailed, how should I say this, like a list of how to go about solving that problem. So not only we think this system is going to blow up in the next 24 hours, but here are the steps you can take to remedy that situation. So that for us is a glimpse of both what we're doing, how we're doing it, how we're going about it, and what we mean by all these different terms. And that was really what I had planned to talk about today.
Awesome. Andre, I must say, like, I'm very pumped to look at all the amazing work you guys are doing. Like, it's very inspiring. Great product. I had few questions along the way, but you were in a great flow, so I didn't disturb. So, but like great development at Autility. You guys are really pushing the boundary. Like I have seen work in digital twins and other, but the way you are combining that with like AI, machine vision, and like other technology, it's gonna make it's gonna leverage the real potential of digital twin. So
That's what we hope.
uh,
Thanks for saying that.
yeah. So yeah. So my first question is like about you mentioned about anomaly detection and like making autonomous decisions based on that. So I'm wondering like uh sometimes decisions can lead to like potential issues. What is like there is like fake detection and you close off the HOX system. So like how do you test out the robustness of your uh, algorithm?
Yeah, that's a really good question, because anomaly detection is not a simple field. False positives are very probable, especially considering we are using unsupervised learning to create these models. So we the typical way of performing, or at least the most introductory way of working with artificial intelligence algorithms is you want to infer something based on already having the answer, right? So you have data that says that, okay, at this time we registered an anomaly. You train a machine to recognize what led to that anomaly. In our case, we don't have that information because it's very rare that these kind of things or systems actually breaks. It's I don't know. We actually had one customer have a component fail, but that was before they became a customer. So might have had some something to do with becoming a customer. I don't know, but the way we go about this is we start relatively conservatively and kind of set. Typically, you have to work with thresholds when talking about anomaly detection. So you have some algorithm that figures out something, like recognizes a pattern, but then you have to explicitly tell it that, okay, this is the threshold I don't want you to go above. If you do go above it, that's an anomaly. We also automate that part. So we continuously tweak that level in terms of both avoiding false positives, false negatives, but it's also very important never to suppress let's say the opposite, like suppress an actual anomaly. That's the worst case scenario. And we do everything in our power to retrain these models as often as possible. The more data they get, the more they will understand. But in every case, to avoid that situation where it doesn't become too specific for that single use case. So that's another typical domain working with artificial intelligence is overtraining, overfitting. And that's something that's quite difficult to handle in practice. How far are you willing to go? The more data you get, the better the model seems to get, but it's also over time going to be overfitted. So you have to compensate for that. It's funny you should mention anomaly detection, because that's something we've been working with for quite a while. That's one of the first things that we started in terms of adding intelligence to the data. And so we have quite a bit of experience with that now, and we are actually in the process of revamping that whole infrastructure. So not only the method, the approach that we perform anomaly detection with, but also the whole infrastructure. So we're moving more and more towards real time with a set of infrastructure that is able to utilize several different algorithms to forecast and several different anomaly detectors to analyze those forecasts. And based on multiple algorithms, surface the highest probability. And outside of that, those three phases, we also have automatic retraining. So, after certain intervals of data coming in, that might trigger another training process. But it's very important to have some manual aspect in there. So you make sure the computer doesn't go absolutely crazy and overfit stuff and just go bananas. So we do have like a period of A/B testing, if you will. So monitoring that, okay, it is actually performing as we expected and the results do look good. There's a little period of that before we completely deploy. So that's pretty much how we handle those things.
I see. And like, I'm just wondering, so if there are, let's say, different types of HVAC system, or do you have like machine learning model for like a particular HVAC system, or do you like combine or fuse this data across different systems and then do machine learning training?
So that again is where this data fusion really shines, because we have one huge generic data model that knows what type of system each system is, and also contains metadata of, for example, the vendor, the supplier of these components. And, leveraging what machine learning does best is look for patterns. Mm-hmm. So we can basically just send the machine to all of this data and utilize dimension reduction principles afterwards to see which parameters actually had the most effect. Was it manufacturer, or was it type? Was it location? those are all things that we can really dig into the models. Because we have a lot of historic data, we can relive, new models over the past to the present. We can apply a new model to the past to see how it would have performed in real time. And all of these things together help us to identify in which scenarios which approach is best. And in some cases, it is system. In other cases, it's location. We actually had a very interesting case this winter where one region in particular was facing one of the coldest winters in a very long time. And that immediately fired some warnings in the system. And that was very interesting because the system was still operating as it should. And we didn't think it was going to break down, but it was very abnormal behavior. And so it was an anomaly. Actually, it was an anomaly because the system was working much, much harder than it previously had.
I see. That's quite interesting. So, uh, I totally like whenever you were presenting about like 3 levels of autonomous, level 1, level 2, and I was like directly like thinking about with Tesla and autonomous driving, they have like also different level, and like it was a great analogy. So, my next question is like I have seen people like some debates around data ownership. Does the data of the building belongs to owner or the systems property manager or the end user? Like curious to know your thoughts on that.
Yeah, that's always an interesting discussion. If you ask building owners, I think the vast majority of them would say that they own the data. Because they're the ones who typically purchase. They've purchased a system that generates data. It should be theirs. From our perspective, honestly, we don't really care that much. We always say that the customer owns the data. If they want to use some part of what we can do, if they just want some data fusion and then send that data to another system, that's completely fine. But we don't all we need to do is we need access to use the data. So that's kind of a prerequisite to be able to use what the intelligence that we've built. But that's the same way in every other software as a service product. But we do say that the customer does own the data, and whatever they want to do with it, that's fine with us. But we do see, there is, especially inside the building with these operational systems, they're delivered often by very large companies who also are wanting to monetize that data. And so in some cases, they just go out straight out and say that, this is kind of a lock-in strategy. We don't want you to have access to that data. Or you have to pay for it, or there are other tactics to sort of hinder the process a little bit, but that really doesn't affect us too much. We operate at the behest of our customers, and if they feel that they own the data, then that's what we operate after. Those are our guidelines.
Yeah, and when you were like talking about the digital twin and machine vision example of how like if there is some object in the fire escape route, like using that camera you could detect, I was thinking it might be also like interesting to have like human as like reinforcement learning agents where you could simulate different scenarios and it could like lead us like what next step you should do to minimize the impact or something?
Yeah, so you're touching on a pretty big subject, but one that is incredibly relevant. And actually, one of the biggest use cases for us is a combination of a lot of the things that I've already talked about. So leveraging a digital twin with all the information inside those BIM files that have information on choice of material, thickness, areas, stuff like that, that we can use in a simulation to simulate, for example, how the sun at a certain point in time over the year will affect the thermodynamics of this building, which we then can couple with reinforcement learning techniques. And that combination is super interesting because as opposed to supervised and unsupervised learning, reinforcement learning is, at least we think, the by far best way of learning the trends in that complicated and dynamic set of interactions. Like, we haven't seen any, or at least any very feasible approach besides reinforcement learning that is capable and able to actually identify the necessary trends and actions that in effect optimizes the outcome. It just seems like reinforcement learning is by far the best approach, because as long as you have good, well, there are different techniques, but if you use an incentive-based approach, then you just have to make sure that you have the right types of incentives, so you don't kind of lead the machine astray and find loopholes to sort of, you know, if you just want to cool the building, it just removes a wall. It's not unheard of. But as long as you have good incentive functions, then, you know, eventually the machine will reach some set of conclusions that reaches the desired objective. So both optimizing comfort and reducing cost at the same time.
I see. And like, I just had a thought, like, so depending on the reward, like the system or machine can behave aggressive or like conservative. So that value is also quite challenging to determine what's the right value. I was wondering, like, so we have BIM model, which has you can do simulation and get analysis, versus digital IoT where we could do the simulation and get what's the actual analysis and energy data. So I'm curious, like, have you find any like comparison or where the BIM model predicted this much energy should be used, but actually there's a lot more or less?
Interesting question. We haven't used that too much because for us, as opposed to maybe a contractor working in purpose-built tools to do those kind of simulations and optimizations, using AI by default will never give you 100%. So that's kind of our principle. We just need something that's good enough. And for us, that approach has been good enough. It gives the rest of the pipeline enough information to do what it's supposed to do in a good way. And we really don't need much more than that.
I see. My last technical question is, you mentioned about cloud-based technology earlier in the interview. Like, what is the tech stack you're using?
Ooh, how much time do we have? It's like on a high level, we're building in Google Cloud. We Our front end is built in Angular using material design as design principles. On the backend side, we use Python to a large extent. We're also dabbling in some a little bit more experimental, like Rust and Erlang, and in some cases even C++. And we use an event-based architecture. So we have basically every component is connected to publish and subscribe brokers, which is really good for real-time applications. We also have a huge set of databases. Off the top of my head, I could probably mention we have a range of typical relational databases. So we use Postgres a lot for that. We use in-memory databases, Redis. We use serverless warehousing, and Google has by far the best solution in the market for this is BigQuery. What else do we use? We have time series databases. We have graph databases. We have NoSQL databases. So it's almost like the whole spectrum. And that's, I think that's a symptom of why, not everyone is taking this approach, is because it is actually pretty complicated to figure out how you put it all together. And it does require all these different components. It's not like we fire up databases just to have them there. They all serve a very specific purpose. We even have a huge, actually, OLAP database. So really high-speed concurrent online analytical and processing database, serving a lot of real-time applications and reporting, actually. So all of these components are necessary. Is there anything I didn't cover? We're on web, tablet, mobile. Ingestion is based on kind of self-built plugins. So we have different ingestion engines and APIs for different protocols, different data formats. All of that is one step at a time normalized so that we can process data in the same fashion. We also have, besides the messaging queues and data storage, we obviously have a real-time processing pipeline. So both stream, but also and batch processing. So it's kind of every aspect that you would expect to see in a typical IoT digital cloud service, but with some extra things here and there that are specifically related to the data fusion part, which is not very commonplace, I would say.
I see. And what bug bothers you the most?
Undefined undefined objects, or forgetting a comma somewhere, or I don't know. There are a lot of these things that just kind of send you on a goose chase looking for why is this happening. And also actually using a lot of open source tools. I mean, open sourcing it is great, fantastic, and we love using it and contributing back. But as all open, or let's say smaller scale companies that, however much they want to contribute to open source, don't have the resources to necessarily document everything, does make things a little bit tricky sometimes, that we have to figure things out for ourselves and debug error messages that just do not make sense in any way, shape, or form. So that has been not insignificant part of our work. So that's up there.
I see. Uh, I wish the technical discussion go on and on, but I have few light questions to end the interview. So I'm just odd the number of things you guys are doing at Autility, like ranging from digital twin simulation AI, and you're involved in so many aspects. So how does a day in your look like? How do you manage all this stuff?
It's difficult because there's, well, typical answer, that no day is the same, but I'll begin by saying this, that yes, we do a lot of things, but we have quite strict principles that allow us to do those things. And what I mean by that is that we, in a lot of fields, we don't necessarily want to compete as a full-fledged alternative to that single component. What I mean by that is if we work within maintenance, for example, we provide a lot of insight to maintenance, but that doesn't mean that we want to become a full-fledged maintenance platform. And that is kind of a general principle for us, is that you have all these different functionalities, areas of software development and domains, but we never go 100%, all the way down to the bottom. We don't develop one solution all the way down to its core DNA. We like to stop at a level where the value we want to provide and the customer is asking and the market is asking is sufficient. And that's a difficult thing, defining what is sufficient and what isn't. But we like to go about the Pareto principle, 80-20, 20% accounting for 80% of the value, in many cases is good enough for us. We don't need 100% and 100% in both. So that allows us to be this broad and to work with all these different technologies. Because without that, I think we would have gotten lost a long time ago.
Yeah, that's a great piece of advice. What's on your travel bucket list?
Actually, I've been quite fortunate in my past to have traveled quite a bit. Now after COVID, I haven't really thought about it too much. We've been almost forced to travel inside the country for once, and that has really been an experience too. A lot of people say Norway is a beautiful country, but you really have to, go and experience for yourself to see it. But if I were to have something on my bucket list, I'm fond of Asia and East Asia. I just really like the culture, the temperature, and also really like to go climbing. So I've heard Philippines is really good for that.
Oh, nice. And is there any book or mentor who made the biggest impact in your life?
Well, Clayton Christensen, Crossing the Chasm, definitely gives some perspective. Also, actually, an author called Bill Olay. He's a lecturer, professor at MIT. He did the hard work of putting together, in my opinion, all the most important aspects that you need to know about and consider to be successful at starting a company. So he took like the best practice from all the other literature and all the other success stories, and also his own, and put that together in a really, really crisp, understandable book called Disciplined Entrepreneurship that I would recommend to any entrepreneur. It's just gives you everything you need to know.
I see. And my last question is, if you have unlimited time and resources, what is one thing you would like to do?
Go to space. That would be cool. Walking on the moon.
Mm. Right now, like they're like it's commercialized, so it's highly possible.
Yeah, highly possible. Still a bit expensive though. We'll see.
Yeah. Awesome. I had a great time. It was nice to host you and know your journey, thoughts, and work. It's quite incredible that you guys have developed.
Yeah, thanks a lot. It was a real pleasure being here and talking and discussing everything we're working to achieve.
Yeah. And I also want to thank Sebastian for staying till the end.
Yeah, that's typical Sebastian.
I see.
He has good stamina.
Bye. Have a nice rest of your evening.